Okay, let's take a look at this problem, calculating solution concentrations. Another type setup. A solution prepared by dissolving 20.2 milliliters of methanol in 100 milliliters of water. The final volume is 118 milliliters. The densities of methanol and water are given. We need to calculate the molarity, molality, percent mass, mole fraction, and mole percent. So this problem is slightly different than the other in that we are given the volume of solute and volume of the solvent. So 20.2 milliliters of CH3OH. That's going to be our solute. 100 milliliters of H2O. That's going to be our solvent. So if we sum these two together, that's going to be our solution. Okay? Now, we are given a volume in milliliters. So we know for molarity, molality, and mole fraction, mole percent, we're going to need the number of moles of solute and moles of solvent for mole fraction. So we're given a volume. So we have to go from a volume in milliliters to a mass in grams, a mass in grams to a number of moles. So this step we use the density, and this step we use the molar mass. So we start out with 20.2 milliliters of CH3OH. To go from a volume to a mass, we use the density, and the density is given here. So what this says is for every 0.782 grams of CH3OH, it occupies 1 milliliter of volume. So we can put right here 1 milliliter, 20, whoops, 7.82 grams. And the unit of milliliters cancels, and when we multiply 20 times 7.82, we get the number of grams of CH3OH, and that equals 15.8 grams of CH3OH. Now, to get the number of moles, we need the molar mass. So in 1 mole of CH3OH, we have 32.04 grams of CH3OH. So my unit of grams would cancel, and I wind up with some number of moles, which is 0.493 moles of CH3OH. Okay, now we calculated the number of moles of methanol. We need to calculate the moles of water, the solvent. So for 100 milliliters of H2O, This density says for every 1.00 gram of H20, we have 1 milliliter. It occupies a milliliter of volume. So 1 milliliter times 1.00 gram. Milliliters and milliliters cancel, so I wind up with 100 grams of H2O. So now I need to use the molar mass to go from grams to moles. In 1 mole of H20, I have 18.02 grams of H20. And when I complete that calculation, my grams, unit of grams, cancel, and I wind up with 5.55 moles of H2O. So we can begin to calculate part A, the molarity. And the molarity is defined as moles solute over liters of solution. That's the volume of the solution in liters. So that is equal to the unit M. So on the side over here, you notice that it gave us the total volume of the solution to be 118 milliliters. So we need to change milliliters to liters. In 1 milliliter, we have 10 to the minus 3 liters, and that's equal to 0.118 milliliters. So now, we can take the number of moles of the solute, which is this. This is our solute. And we can say 0.493 moles of CH3OH divided by 0.118 liter of H2O. And when I do that division, I'm going to get 4.18 moles per liter. So that is the molarity of that solution. The molality which is moles of solute over kilograms of solvent, a different definition than molarity. Molality is defined by little m. So, we know that 0.493 moles of CH3OH is the moles of the solute. Now we have to find the mass of the solvent in kilograms. So, we found out that the volume to mass conversion gave us 100 grams of water. So we need to change that 100 grams of H2O to kilograms. So in 1 kilogram, we have 10 to the third grams. So that is equal to 0.10 kilogram of H2O. So this is kilograms of solvent. So we simply divide by 0.10 kilograms of H2O, and that's going to give us 49.3 moles per kilogram, and that is equal to little m. Okay, let's look at C, percent by mass. This is part C, this is A, and that's B. So we need the mass of the solute over the mass of solution times 100%. So the mass of the solute, we found that to be 15.8 grams of CH3OH. And the mass of solution is going to be 15.8 grams plus 100 grams for H2O. So this gives us the mass of solution, because this is our mass of solute, this is our mass solvent, and when we sum those together we get the mass of the solution, and that is going to equal 15.8 divided by 115.8. So we wind up with 0.136 times 100. And that is 13.6%. So what that says is for every 13.6 grams of CH3OH, we have 100 grams of solution. Now, the last two pieces, which is D and E, the mole fraction of solute is equal to N of solute divided by N of solute plus N of solvent and recognize that N of solute plus N of solvent is actually N of solution. So the number of moles of the solute is going to be this guy right here. So that's going to be 0.493 divided by 0.493 plus the moles of, this is moles of solute, plus the moles of solvent, which is going to be this guy right here. That's going to be 5.55. So we divide 0.493 divided by 0.493 plus 5.55, and our mole fraction is 0.0816. So that is equal to chi of solute. Now to find part E, we take the mole fraction 0.0816, multiply that by 100%, and that is equal to 8.16%, and this is our mole percent. Okay, so we've gone through somewhat intensively all these units of calculation, all these units of concentrations. So the difference in this problem and the prior problem that I worked in class and in a video, we're given volumes. So we have to go from milliliters to a mass, and from a mass to moles. And as I said, this is using the density. And from here we use a molar mass. Practice this problem on your own and see if you can come up with the correct answers. This would be a great exam question. This would be a good question for exam or one similar type.